Let's go ahead and tackle altimeters now and some very tough test questions that deal with them. The main problem I see is how books and people teach the way an altimeter reacts to changes in pressure and temperature. So let's analyze this teaching method and then introduce a much simpler one. From high to low or hot to cold, watch out below. Okay, so if I go from high to low, assuming that it's pressure, the altimeter reads lower because it looks below, or, wait, I need to look below because the altimeter reads higher because in warmer days the pressure levels are raised or lowered, so the altimeter gets tricked into thinking that it has become a VOR receiver. No. I don't know about you, but this teaching method always confused the heck out of me. People learn better by association, by being able to relate to something they already know. So let's do that instead. Let me ask you, if you were blindfolded and was brought to a location where it was very cold and hard to breathe, would you not believe you had been brought to the mountains? Well, if you answered yes, then you should have no problem understanding how an altimeter works, because the altimeter works the exact same way as your brain does. So, first let's tackle temperature changes, then pressure changes, and finally a test question or two. Normally, as you climb in altitude, the temperature decreases, and vice versa, it gets hotter again as you get closer to Earth. So you yourself believe that you're climbing higher and higher as the temperature decreases. But what if you were still at sea level and it got fairly cold all of a sudden? Would you still think you were at sea level, or that you went to a higher altitude? I'm pretty sure you would probably believe that you had climbed into the mountains as the temperature got colder. So does the altimeter. The altimeter reacts to temperature just like your brain does. Let's say you were flying along at 2,000 feet and that the temperature would start gradually dropping from a temperature of about 12 degrees to 0 degrees centigrade. As your brain is tricked into thinking it has climbed to a higher altitude, so is the altimeter, which will display a higher indicated altitude than the one it's actually flying at, your true altitude. Keep in mind that the animations in the current slide are only dramatizations of the effects of temperature changes, as the altimeter is only affected by an approximate correction of 4% for every 10 degrees centigrade. But I hope you still get my point. Remember, if you get a question that says something like, "What would the altimeter read if you flew into an area of cold weather?" change the question to, "What would you think if you flew into an area of cold weather?" And the answer is, you would think you had climbed into the mountains, and so would the altimeter, giving you a higher indication, while the altitude you're flying at, your true altitude, is actually lower. Now let's tackle the pressure. By the way, same exact system as the temperature. Like temperature changes, pressure changes also affect your body and brain. If you ever tried playing sports at high altitudes, you probably know what I mean. As you probably know, the pressure decreases about 1 inch per each 1,000 feet you climb, and vice versa. So you yourself believe that you're climbing higher and higher as the pressure decreases. But again, what if you were still at sea level and the pressure dropped all of a sudden? Would you still think you were at sea level, or that you went to a higher altitude? Well, try playing the same exact sports again, and the answer would be evident. You have climbed to a higher altitude. The same happens for the altimeter. The altimeter reacts to pressure changes just like your brain does. So let's say again that you were flying along at 2,000 feet and that the pressure would start gradually dropping from a standard pressure of approximately 27.92 to 23.92 inches of mercury. As your brain is tricked into thinking it has climbed to a higher altitude, so is the altimeter, which will display a higher indicated altitude than the one it is actually flying at, your true altitude. So remember, if you get a question that says something like, "What would the altimeter read if you flew into an area of low pressure?" treat it the same way as temperature questions, and change it to, "What would you think if you flew into an area of low pressure?" The answer is, you would think that you had climbed into the mountains, and so would the altimeter, giving you a higher indication, while the altitude you're flying at, your true altitude is actually lower. Now, what happens when we adjust an altimeter for pressure? Well, let's say you're flying along at 2,000 feet and the current altimeter setting is 30.42 inches of mercury. As you keep flying along, you forget to reset the altimeter setting and the pressure gradually drops to 29.92 inches of mercury. As you can see from the animation, because we went into an area of low pressure, the altimeter thought that we had climbed and is now giving an altitude of 2,500 feet, which is the indicated altitude. But you would still be actually flying only at 2,000 feet, which is your true altitude. Now, if we do adjust the altimeter setting to the correct pressure of 29.92 inches, the altimeter goes back and corrects the error and indicates properly 2,000 feet, which is the same as your true altitude. This is something to remember, because there are questions that ask, for example, if a pilot changes the altimeter setting from 30.11 inches to 29.96 inches, what is the approximate change in indication? If we then apply the same method, not changing the altimeter setting would make the altimeter read higher because of the lower pressure. So we don't change the altimeter setting and the altimeter reads higher. But the question says to change the altimeter setting. Well, then the opposite must be true as well. The altimeter reads lower. Now that we established that, how much lower? Approximately 150 feet lower. Because if 1 inch equals 1,000 feet, then 0.15 inches equals 150 feet. If you're wondering where I got the 0.15 inches, well, the initial pressure was 3011. The final pressure was 29.96 given by the question, so I just subtract 29.96 from 3011 and I get 0.15. Next, let's complicate things and look at some really tough questions. Now let's tackle one of the most confusing questions that deal with altimeters. The question says, en route at flight level 290, the altimeter is set correctly, but not reset to the local altimeter setting of 30.57 inches of mercury during descent. If the field elevation is 650 feet and the altimeter is functioning properly, what is the approximate indication upon landing? Before we get into solving it, let's take a peek at what actually happens when we start flying above 18,000 feet. Let's say that you depart an airport at an elevation of 12,000 feet with a current altimeter setting of 3042. And let's say that you are assigned an initial altitude of 18,000 feet. Once you reach 18,000 feet, if you're following procedure correctly, you would now be resetting your altimeter to 29.92, which is pressure altitude. As you can see, this affects the altimeter, and your indicated altitude is now 17,500 feet. Because you were assigned 18,000 feet by the controller, you're going to climb back to an indicated altitude of 18,000 feet. But your true altitude, the altitude above sea level, is now actually 18,500 feet. So, if we now, for some reason, needed to head back to the airport, it's pretty obvious that upon landing, our altimeter would read 11,500 feet, or in any case, 500 feet lower than true. So, for the original question itself, an airplane flying at 29,000 feet would have an altimeter setting of 29.92. It also flies at pressure altitude. And if the correct altimeter setting was entered in the Coleman's window, the altimeter would correctly indicate 650 feet upon landing. But since the altimeter was not reset to the correct pressure of 30.57, and instead left on 29.92, we can see that we have gone from an area of low pressure to an area of high pressure. High pressure is at a lower altitude, so the altimeter is going to read a lower altitude. How much lower? Approximately 650 feet lower, again doing the math between 3057 and 2992. The altimeter is going to read 0 feet, because the elevation of the field was 650 minus 650, 0 feet. Well, I hope this explanation has cleared any doubts you had on how altimeters work. And for more videos like this one, or to purchase our software, please visit passfaaexams.com.